Right, so in this video what we're going to be doing is going through the National 5 applications of maths from 2019, and we're doing the calculator paper, which is paper 2. So our first question, before we do that though, actually, if you have any questions about any of the working or anything as we're going through, or after, feel free to leave a comment and I will get back to you as quickly as I can. Just with any clarifications you might need. So here we have question 1. So we have Sam buys a rare stamp for stamp collection at an auction. He buys the stamp for £920. The stamp increased in value by 7% for each of the first 2 years, and then it decreased in value by 4% in the third year. Calculate the value of the stamp after those 3 years, giving my answer to 3 significant figures. So when we're doing this, I'm going to go through and I'm going to highlight important bits through the paper, because a lot of National 5 applications is recognising what is important. So this one here, 7% in the first in each of the first 2 years, and 4% in the third year. So, and the final bit that's important that we need to make sure we don't forget is our 3 significant figures. So looking at this, if it's increasing by 7% of the first 2 years, so in this case it's probably just as easy to do it kind of step by step rather than doing it kind of all in one go. There's compound interest calculations which you can find, but in this case, end of year 1, it is going to be 107% of our £920. Using your calculator, there's 3 different ways you can put this in. You can put it in as 107 over 100, 107%, or 1.07. They will all give you the same answer, which is £984.40. Once we've got the end of year 1, we can work at the end of year 2. So year 2, again, we're still increasing by 7%. So it's 107%, but this time we are finding 107% of the £984.40, which gives us, give me a second here, we get 1,053.308. Any gaps I'm taking here so I can actually put things into my calculator, because I'm doing it as I go to make sure that I'm getting it right and that you have time to keep going with me as well. So that's end of year 2. And then lastly, we've got end of year 3. So this year 3, it said it decreased by 4%. So that means it's 96% of what it was originally, of our total, which is £1,053.308. So 96 or 0.96 when into our calculator. We can either put 96%, 0.96, or 96 over 100. They're all exactly the same and will give us the exact same answer. So there we get £1,011.17568. So therefore my answer is, so the value is 3 significant figures. So my third significant figure is this one here. So that's saying to round to the nearest 10. So we get £1,010. Here we've got 4 marks in this first question, so we need to figure out or see where these marks come from. So if you do your working this way, it is 1 mark for year 1, 1 for year 2, 1 for year 3, and 1 for our rounded version. That is it for question 1, so let's go on to question 2. Here we are with question 2. So we have a bottle consists of a cuboid and a cylinder. Volume and dimensions are shown on the diagram. We need to calculate the volume of the whole bottle. So for a cuboid, we know volume is length times breadth times height. For a cylinder, we have volume is pi r squared h. The heights are going to be different for these, obviously. So for our cuboid, we have 8, 4.5, and 10 as our three measurements. So it's 8 times 4.5 times 10. So when we do that, we do 8 times 4.5 times 10. We get 360. And it is going to be centimeters cubed because we're talking about volume. For our cylinder, we have pi times r squared times h. So we need to look here. So this is telling us the whole distance across our cylinder is 3. The radius is just from the middle to the edge in any direction. So if the whole way across is 3, our radius is going to be 1.5, which we need to square. And our height of our cylinder is 4, as we can see here. So our cylinder is pi times 1.5 squared times 4, which gives us 28.274 and some extra, which if I round we get 28.27 centimeters cubed. So the total volume is what we get when we add them together. So 360 plus 28.27, which gives us 388.27 centimeters cubed as our answer. Remember, lots of this course is to do with geometry and measurements, so we need to make sure that for every question, if we can, we have our units on each one. So here, first mark is for correctly substituting into our cylinder formula. Second one is for getting our answer for that. Our third mark is for correctly finding the volume of the cuboid. And then final answer is correct for there. And for the last mark, it does say in the marking instructions that your units have to be written down. So that's the thing you need to be careful of. Like I said, we're doing applications here, and lots of this is to do with measurement and geometry and distances. So we need our units every single time. So here we go with question 3. So we have a graph showing how many pounds sterling could be bought for €1 during December of 2017. So we have Daniel, who has changed €250 into pounds at 9 on the 7th of December. So if we do that information, just kind of looking at our graph. So the 7th of December at 9 is here. So if we follow this up here, that is going to tell us our exchange rate. So looking there, we need to be careful. So we're on our axis here. We've gone from 0.85 up to 0.86. There's 5 gaps in between. So that means each one is going up in 0.002s. So it's 0.852, 0.854, 0.856, 0.858, and then 0.860. But obviously we don't write that 0 on the end. So that's our first piece of information. So we know for A that £1, oh no, it's not £1, it's €1, excuse me. So we know that €1 is equal to 0.852 pounds. So let's see what we've got. So we changed €250 to pounds sterling at that time. So that tells us that €250 is, we're going to just take those and multiply them together. So 0.852 times my 250. And we get 0.852 times 250. We get £213. Right, part B, so keeping going, reading on. So we have Daniel's working in France. He bought a laptop costing €400. He calculated that it was equivalent to £334.80. We need to work out when Daniel bought his laptop and why. So for part B, it's telling us that 400 euros gave us £334.80. So our graph tells us what €1 is equal to. So we need to find out, using that, what €1 is. So divide there. I'm going to divide by 400 to get €1, and whatever we do to one side when we're working with ratios, we have to do to the other side as well. So I do my £334.80 divided by 400, and I get 0.837. So now we need to look at our graph and find 0.837. So 0.837, so that's going to be here. If I go along to here, I can see this is this point here, and I can go down, and I can say that Daniel bought his laptop on December 9th, because this is when the exchange rate was 0. This is where I'm trying to do too many things at once. So as this was when the exchange rate was 0.837. Okay, so there we go, got myself out of that mess eventually. So here we go for this question, where our marks come from. So we have 1 mark in part A for our 0.852, and then our second mark for getting to our 213. So for part B, we get 1 mark for our 0.837, and then our second mark for correctly interpreting that it is December 9th and saying why. Question 4. So we have Karen buys and sells silver, gold and platinum. A table shows the price per ounce of each of these metals on the first trading day of each month over the past year. So we get told that Karen bought 1 ounce of gold, so 1 ounce of gold on the first trading day in March, and she sold it on the first trading day in September. And we need to calculate the percentage loss that Karen made. And here is, it also says we need to do it to 2 decimal places, so that's the other important bit we need here. So looking at our table, I've pulled it over to the side, it was just underneath, and I've kind of rearranged things a little bit, but that's fine. So we're looking at gold, so we're going to be looking at this middle column. We know that she bought it in March, so this is our value for the March date. She sold it in September, so that's that one. And so we need to work this out as a percentage loss. So before we can work out the percentage loss, we just need to figure out what our loss is. So the loss is going to be equal to 1,210 take away 1,140, which is, should really do this in my head, but it's always worth just double checking with a calculator if we can, because we all make mistakes. So the loss is 70. It's in US dollars, so that's fine. So percentage loss. So it's equal to our loss divided by original value times by 100 to change it into a percentage. So we have 70 over our original value, which is 1,210, times by 100. So again, putting that into our calculator, we have 5.78512 and some extra. So it says 2 decimal places, so we can do that without rounding first, and then 2 decimal places. So that's saying we need to look at this third one here. So it's asking, is this closer to 5.79 or 5.78? And with the 5 there, it's closer to the higher one. So we get 5.79% as our loss. So marks for this question. The first mark is for correctly getting the 1,210 and the 1,140, so it's for both of those values there. Our second mark is for knowing that we have to do the subtraction, so the 70 over the 1,210 times 100. And our last mark is for getting our answer and rounding it to our correct number of decimal places that were asked for. Okay, so question 5. We have a hotel is having a swimming pool built. It's in the shape of a rectangle with 2 quarter circles, which is shown below. The swimming pool is going to have a safety rail fitted around its edge. There's going to be 2 125 centimeter wide gaps to allow access. The safety rail is sold in 3 meter lengths. Each 3 meters costs £11.49. We need to calculate the minimum cost for the safety rail for the pool. So first things first, we have to work out the perimeter of the shape. So we're working out the distance all the way around here. So we've got a few different things we need to work out. So we can add in some other things we know. So we know that this bit is 10, because that is the radius of our quarter circle. And when we have the radius, it doesn't matter the direction, it's always the same. And that's an M in there, not anything else. I started to write centimeters, but it's in fact meters. The top bit here, that's also 36.5. And then we have these two parts here. We've got this bit here and this bit here. So altogether, those 2 quarter circles make a semicircle. So we need to work out how long the semicircle is. So that's one of our first things we need to do. So our circumference, we know, is pi times diameter. For this, our 10 is half of our circle. It's just from the middle to the edge. So we need to double it to work this out. So it's going to be pi times 20. So that is 62.83 meters. But in fact, our perimeter is going to be, so perimeter, so we've got 2 lots of 36.5. We also have 2 lots of 10. And then we have half of our circle, which is 62.83. So when we put that all in the calculator, we end up getting the perimeter of the pool is 124.415 meters. We have one issue with that though, which is this bit here, which are 2 125 centimeter wide gaps. So with those gaps, we need to take them away. 125 centimeters as well. We need to know that 125 centimeters is equal to 1.25 meters. So with that, so our rail is going to have to be equal to our 124.415. Take away our 1.25 for one gap. Take away another 1.25 for the second gap. So altogether we're taking away 2.5, which gives us the rail is 121.915 meters roughly. Once, because we've kind of rounded in there with our circumference. So now we know it's sold in 3 meter lengths. So we need to figure out how many lengths we need. So total lengths. So we have to divide this by 3. We can only buy it in 3 meters. So we can't kind of have part of a length. So there, divided by 3. So when we divide by 3, we get 40.638, You can't buy 0.638 of a length, so we need to buy 41. So our cost is going to be then 41 times my £11.49, which is £471.09. So this question's worth a lot of marks. It's worth 5 altogether. So let's see where our marks come from. So our first mark is for knowing how to find part of a circle. So now we're having to do our circumference divided by, like, halving our circumference. So it's that bit in there that I've got there. Or quartering it and getting the answer for it. Our second mark is actually for what the answer to that is. I've done it in here. I've not actually separated it out. But we would still get our second mark in there. Our third mark is for calculating the perimeter of the pool, which is our 120, our third mark even, is for the 124.4. The third mark is for both these bits here. So for knowing we have to take away our 1.25s and to do our divide by 3. And then our last mark is for knowing that it's 41 times 11.49, getting us our £471.09. Okie dokes, we've got question 6. So we've got Denisa bought 375 shares for £450 per share. She later sold them all for £5.20 per share. She had to pay commission of 2.7% of the total selling price. Calculate her total profit. So she bought them for our total, so it's 375 times by my £4.50. So total cost for all the shares that she bought was £1,687.50. Are sold, so she sold them all, so 375 again, times my £5.20. So 375 times £5.20, that comes to £1,950. However, that's not what she actually got, because she has her commission. So this is 2.7% of our 1,950. So into our calculator, either 2.7 over 100, 0.027 or 2.7%. As long as you've got one of the newer Casio calculators, it's got like a literal percent button, so you can do it that way. So we get £52.65. So profit that she made is going to be equal to our £1,950. Take away our original price, so £1,687.50, and then take away again our £52.65. So altogether we have that her profit would be £209.85. So where do the marks come for this question for our 3 parts? So we get 1 mark for finding the sale price, 1 mark for finding our commission, and then 1 for knowing that we had to calculate the profit by doing our 2 takeaways and getting our £209.85 as our answer. That's it for question 6. So next up, hopefully we can count question 7. Right, so we have birth weights of babies in a hospital in 2017. We have the sample weights in kilograms shown there. We need to calculate the mean and our standard deviation. So to calculate our mean, what we're doing is we're adding them up and dividing by how many we have. So we have 2.5 plus 4.5 plus 3.7 plus 3.1 plus 3.8 plus 3.4, all divided by 6, which gives us an answer for our mean of, when we put it in our calculators, 3.5 kilograms. Right, so when we're doing this, there's two formulas for standard deviation. I use one rather than the other because it always works and doesn't depend on our mean being nice. So we have our sum of x squared minus the sum of x all squared over n all over n minus 1. So this is the second formula that we're aiming for. So to do that we need two things. We need the sum of x and we need the sum of x squareds. So we've got to add up all our x's, add up all our x squareds. So we have 2.5, we have 4.5, we've got 3.7, 3.1, 3.8 and 3.4. So sum of x, so that's just what we get when we add all those together. And when we add all those together, we get 21. And then our x squared, so we have 2.5 squared, which is 6.25. We have 4.5 squared, which is 20.25. We've got 3.7 squared, which is 13.69. 3.1 squared, which is 9.61. 3.8 squared, which is 14.44. And we've got 3.4 squared, which is 11.56. So that one gives us our sum of x squareds. So sum just means total. And for those, when we add all those 6 numbers together, we get 75.8. Exactly. So we can now put these numbers into our equation. If we're worried about which is which, sum of x, this one here, that's the one that's in this bracket up here. And our sum of x squared, that's our one that's here out the front. So we just take those and put our numbers in. So we get our standard deviation is the square root of 75.8, take away 21 squared, over n, which is 6, and then all over 6 minus 1. At this point it's a case of just putting it into your calculator as is. We should hopefully all have calculators that are able to do this, so the kind of newer Casio ones. If not, you should have gone through how to use your calculator properly, so it shouldn't be a problem. And we get our standard deviation of 0.678. And it is kilograms because it has the same units as the data that we get given. So I'm going to go through the marks for A, from where they come in first before we go on to part B. So A, easy enough, 1 for our 3.5. Using the method I've got there, we get 1 mark here for our 21 and our 75.8, our second mark for substituting incorrectly, and our third mark for getting our answer there. So here, this last, the comparison statements are done really poorly, usually, and we need to be really careful with how we're stating them. So this time, the question is talking about the weight of babies, so our statements need to talk about the weight of babies. And because we're talking about weight, it's either going to be heavier or lighter, or the words we're going to use. So on average, so when we're talking about the mean first, because we need to compare our mean and our standard deviation. So we had, in 1987 it was also recorded, so we know the mean weight was 3.4 and the standard deviation was 0.95. So first things, on average, if we're going to say, so we'll say in 1987, the babies weighed, so in this case it's either more or less, so we're looking at our comparison. So we had 3.4 here, and we've got 3.5 here. So we can say, so they weighed less than in 2017. So that's our first comment. So we need to mention that on average needs to be about babies and whether they weighed less or more. So then our second statement is about our standard deviation. And our standard deviation tells us the variance of our data, so how spread out it is. So in here, we've got 0.95. In our original data, we've got 0.678. So this is telling us because it's bigger, it is more varied. So we can say, however, compared to 2017, in 1987, the weights of the babies were more varied. So here, like I said, because the question is talking about babies, our statement needs to say babies and talking about their weights. If it was talking about times, we would have to talk about time. Whatever it is, we need to talk about it in the context of the question. So there, 1 mark for each statement, 1 based on the mean, 1 based on the standard deviation, has to be in context. So this question just keeps on going. So the lengths and weights of 8 newborn babies are recorded on the table as shown there. We need to draw on the grid a scatter graph to show our data. We need to draw a best fit line, and we need to use that line to estimate the weight of a baby who was 50 centimeters when they were born. So here we've got 46 centimeters as our length and 2.7 as our kilogram. So here we can see we got 10 for 1, so each one nice and easy, 0.1. So starting off, we've got 46 here, and we know our 46 gives us a 2.7. So marking 46 and 2.7. I'm just going to tick these off as I go so I don't miss any. 47 is 2.8, so that one's in here. Done that one. 49, and we get 3.5, so that's there. 51 gives us 3.4, which is here. 52, we have 3.4 again. Oh, I did that wrong there, didn't I? Let's double check that. So let's look. So here, 51, 3.7. What I did was I read across there. So 51 and 3.4. This is just a good teaching point of making sure you mark and double check what you're doing. So that wasn't correct, so I need to go back in and fix it. So for 51 it should be 3.7, which is in fact up here, not where I had it to start with. We have a 52 that's 3.4 though, which was where I had that one. We have a 52 that's 3.7 as well, in there. We have a 54 up at 4. And we have a 55, which is at 4.4. So there we have it. So for this one, we get 2 marks if we have 1 mark if we have at least 4 of those correct, and our second mark is for getting all of them correct. I'm not going to tick this as I kind of go, but that's what the marks are for. For part B, we need to draw a best fit line. You need to make sure when you're doing this that it is as close to kind of in the middle of things as we can. So something roughly like that. So if we look at this, we've got kind of 3 below, 3 above, and 2 on my line. So that would be a reasonable best fit line. The way they mark this is actually you get like a kind of grid, and if it's in between their guidelines, you get your mark. If it is out with your guidelines, you don't. But for part 3, we need to use our best fit line to estimate the weight of a baby who's 50 centimeters when they were born. This is based on your best fit line. So you go up from your 50 kilograms. Let's use in a different color, and I'm just going to use a line to go up. So we go up to here, and we can go across. That's not what I was trying to do. I wasn't trying to move that one. I was trying to make a new line. Here we go, and then I can go across from there to here. So we can say that according to mine, it would be 3.4 kilograms. And for part 3 there, as long as your answer relates to your best fit line, you will get the mark. We're still not done. We have a part D as well. So we have baby milk powder sold in 900 gram packets. Feeding guide from one of those packs is shown here. We get told then that each level scoop contains 4.5 grams. Baby Andrew weighs 7.1 kilograms. So that tells us that from our table, the only piece of information, the only line that we need to pay attention to is this one here, because 7.1 is in between those two values. So the rest of the table is extra information we don't actually want or need. We then keep going. We need to determine whether a 900 gram pack of milk powder will last 1 week, using our working to justify our answer. So if we look at our table, so we know that each scoop contains 4.5 grams of milk powder. And we know, so number of feeds per 24 hours is 4, and each feed requires 8 scoops. So the scoops for a week per week. So we've got 7 days, so we're doing 7, and then 4 feeds a day, and 8 scoops per feed. Gives us that we need a total of 7 times 4 times 8. So we need 224 scoops in 1 week. So then we need to work out what the weight of that is. So weight is going to be 224 times by 4.5, which gives us 1,008 grams. So we can see we've got that's too much, so we need to make a comment. So therefore, no, it will not be enough. As 1,008 grams is more than 900 grams. So here marks for this part of question 7. What we get are, firstly, we get a mark for picking the right row in a table. So any kind of information that shows us that you've picked the right information, so whether that be the 4 there or the 8, either or gets us our first mark. Our second mark is working out the grams for 1 week, and then our second one is our second mark, not even our second mark, our last mark, third mark, is for making a comment. It's not enough because that is more than 900 grams, which is how much 1 pack has. Here we go, we're done with our baby question and we're on to question 8. So we have a new road bridge has been built. A worker paints 367 lines along the centre of the road. So each line is 4 meters long and there's a gap of 2 meters between each line, and the first line starts at the beginning and the last line ends at the end. So we need to calculate the length of the bridge. So when we're doing this, we have 367 lots of 4 meters, which is our lines. However, we do not have 367 gaps. We only, in fact, have 366 gaps because we're going line, gap, all the way to the end where we just have a line but no gap. So we've got 1 less gap at the end. So it's plus 366 times our 2 meters. So we get a total there of 2,200 meters. So here we have 2 marks for this question. Where the marks come from are we get 1 for knowing that there are 366 gaps, not 367, and then our final answer of 2,200 gets us our second mark. So this question keeps going, as a lot of questions in this paper do, as you will have seen. So 2 cables support a section of the bridge. Section forms 2 right-angled triangles as shown in the diagram which I've got there. We need to calculate the total length of the cable needed for the section of the bridge, and we're not to use a scale drawing. So here we've got 2 right-angled triangles, so it's going to be Pythagoras, and we are in fact going to have to do Pythagoras twice. So we've got first of all we have this triangle that I'm drawing over, which is 300 and 295. And secondly, we've got another triangle here, which we only have one piece of information for at the moment, which is 600 meters. So we need to work out Pythagoras with our first triangle to find this side here. And then once we've found that one, we can work out that one there, just using different colours to distinguish my question marks there. So for the first one, we're finding a shorter side of my triangle, because we already have the hypotenuse. So when we're finding the shorter side, we're going to subtract. So we get a squared is equal to c squared minus b squared. So we have 300 squared, take away 295 squared, which gives me my a squared. So 300 squared, take away 295 squared, so I get 2,975. I can square root this if I want to. So square root of 2,975, which is equal to 54.5435, and it keeps going. So one of the things I said, we can square root this if we want to, but we don't actually have to, because when I'm finding this side here, when I'm doing my Pythagoras, if I write in my side, so if I call this one B and this one A, when I'm doing my Pythagoras, I need to do c squared equals a squared plus b squared. I have, in fact, found a squared already. I know what a squared is. I don't need to use a, I can just jump straight to a squared. Obviously you can use this and you'll get the same answer, or a very similar answer. It doesn't actually make much of a difference. But we can put it in, so we can put in our 2,975 plus my b squared, which is going to be 600 squared. So c squared is 2,975 plus my 600 squared. So it gives me c squared is equal to 362,975. So my c is the square root of that. So I get 602.4740 and some extra bits. So I round that to 602.47 meters. So the cable is my 2 hypotenuse. So the total cable length is going to be equal to my 602.47 plus my 300, which gives me 902.47 meters. So my marks for question, this part B of this question, we get first mark for knowing that we have to do Pythagoras and we've substituted correctly in. And then we get our second mark either for this line here or for this line there. That's where we get mark number 2. Mark number 3 we get for the correct strategy in here, so knowing we have to add. Then our final mark we get for working through that second set of Pythagoras and adding the 2 values together. Right, so with question 9 we have David is writing his new book. He spends 210 hours on his research, 96 hours on meetings, and 234 hours writing the book. We need to construct a pie chart to illustrate the information. There's an additional diagram later if we make a mistake. From marking this last year, one of the issues that I came across was a lot of people didn't put any working whatsoever on the page for how they worked this out. So first we need to find our total hours. So total hours spent, so we've got 210 plus my 96 plus my 234, which tells me altogether this person with their book spent 540 hours. So now we need to work out our angles for our pie chart. So we can work out what degree for each hour as a way of doing it. So we know that our total 360 degrees gives us 540 hours. So we want to figure out that 1 hour is how much of the circle. So we're going to do 360 divided by 540, which gives us 2/3 of a degree, which isn't very nice, but that works okay for us. So we get 2/3 of a degree per hour. So 210 hours, not 210 degrees, so 210 hours is 2/3 times 210. So we get 2/3 of 210, which is 140 degrees. For our 96 hours, we have 2/3 of 96, which is 64 degrees. And for our 234 hours, we have 2/3 of our 234. So when we do that, we get 156. We should double check that when we get those, they add up to 360, which they do. So now we create our pie chart using those values. Rather than creating a pie chart here, I'm just going to stop, and magically appears the pie chart which I've created in Excel instead of using a protractor. But you would obviously have a protractor in your assessment. So there you go, magic pie chart appearance. So that's what my pie chart would look like. When we're doing this, you won't necessarily have colours, so you should write in it research, which I can't spell apparently. So research, which is the orange bit, meetings, which is my yellow one, and writing, which is the green one there. If we double check, our green one's obviously biggest, research is the smallest, second, and then meetings is my smallest one. So with this, marks come from, first of all, working out it's 540 hours altogether. Second one for calculating all of our angles. And then our third mark is for our pie chart, which is consistent with our working and which is drawn and labelled correctly. Right, so keeping going, so we've got the publishing company produced the following table to show all the tasks involved in publishing a book. So we have activity A, illustrate the cover. Activity B, write the first draft. Activity C, research ideas. D, edit the book. E, publish the book. F, rework the book. G, proofread the book. H, choose the title. I, copyright the book. And J, do the ISBN. We need to complete the table below to show all of our tasks. So when we're doing these, I'm going to score them out or highlight them as I go. We have our preceding tasks, which is our important bit, and this preceding task column tells us where we start. So we look down here, we find our one that has nothing preceding it, and that has to go at the start of our table where there is nothing before it. Preceding just means before. So our first one that we need to put in is this one here, C, research ideas. So we can put our letter C into our first part. Then now we're looking for what requires C to have been done. So we're looking down our preceding task, looking for C, which we have here. So this, our first draft, goes into our next part there, which was B. So that one means that we've got this one in here as well. That one's done. We have E in there already as well, so I can kind of highlight that one. They've put that one in for us already, which is our last step, which is to publish the book. Now, if we look at our table, it splits into 3 separate parts. We've got one that has 3 bits, one that has 2 bits, and one that has 2 bits. So these last 1, 2, 3, 4, 5, 6, 7 parts get split into 3 different trains of events that can happen at the same time. So we should see that there are 3 events that have a preceding task as B. So we do. We've got D, edit our book. We've got H, choose the title. And we have I, which is copyright it. So we need to see how many tasks follow that one. So if we start with B, edit the book, that becomes D. So what happens after that? We have to rework our book. Is there anything that's after that? Yes, there is. There's G, proofread it. So that's our chain of 3. So those are the 3 that are going to go on the top. So edit our book was B. Give me a second while I work out my kind of colours here. Edit book is D, even not B. Requiring D was to rework the book, which was F. And then we needed to proofread it, which was G. So we've got D, F, and G, which are done. Just scoring those ones out there instead of actually highlighting them there. Picked the wrong thing. And then my last 2, because they're both 2s, it doesn't matter which order they go into. So if I look at my kind of here, if I choose my title, I can put that one in my middle row. And the one that requires H to have been done, so that's H, is to illustrate the cover. So that means that A has to go after H. And the last 2, so we've got H done, and I've got A done, changing colour in my highlighter here as well. But it's all just to show that we've got the same thing, we've got this all done, it doesn't really matter too much. And then in the bottom we've got our copyright and our ISBN. So marks for this question was, we have 1 mark if we have at least 5 in a correct sequence. So with this, that means if we've got kind of here following there, we've got 5 in a row that are correct, or we've got 5 in a row that are correct, or 5 in a row that are correct, or kind of any 5 in the right sequence. It doesn't necessarily need to be in the right places, but in a sequence. And then the second mark was just for having the whole thing correct. So if you had everything in the right place, you get 2 out of 2. Keeping going with this question, so the books are to be packed in boxes for transporting to bookshops. The dimensions of the book and the internal dimensions of the box are shown in the diagram. The book needs to be laid with the cover facing upwards inside the box, and they must be aligned in the same direction. Calculate the maximum number of books that can be packed into each box. So with this, we've got 2 different options. So it says that the front cover must be facing upwards in the boxes. So we have 2 different options, which is one with the books in kind of this orientation that I've drawn there. And we also have the option where the books are in that orientation there. So we can rotate them, but we need to keep the cover facing up the way. So in these 2 different orientations, we need to see how many books we can fit inside the box and then make the decision on which one is better. So with them, how they're drawn there, so we're going to have to look at the length, the width, and the height. So how many can we fit along the length, how many can we fit along the width, and how many can we fit along the height? So we know that this is 125 millimeters, the height is 20 millimeters, and we've got 195 millimeters that way. So looking at our box, we've got 1 meter, 50 centimeters, and 20 centimeters. All our units are different, So we need to make sure everything is in the same units. So I can go round and just change things. We can either put everything into millimeters, or we could put everything into centimeters, or everything into meters. Probably putting everything into centimeters makes the most sense. So 20 millimeters, that is 2 centimeters. 125 millimeters, that is 12.5 centimeters. 195, 19.5 centimeters. And then the last one that needs change is my 1 meter, which is 100 centimeters. So no, everything is in centimeters, so we are good to go. So looking at the lengths, it doesn't really matter which one's length and which one's width. But I'm going to say this is length here, so length is 100 centimeters. And with the book in this direction, the length of the book is 12.5, so we can see how many we can fit by doing 100 divided by 12.5. And that gives us that we can fit a total of 8 books along the length. The width is these measurements here, so we've got 50 there and we've got 19.5 there. So if we do 50 divided by 19.5, see how many we can get. And that gives us 2.564, but we can't put part of a book. So we get 2.56 and something else, which in this case is just 2, because we can't chop the books up or liquidate them or do anything else silly like that. Right, our height. So it's 2 centimeters and that's 20 centimeters. So that's nice. 20 divided by 2, which gives us 10 books. So we can fit 10 stacks of books on top of each other. We can fit 8 along the length and 2 across the width. So for this one, our total, we take those numbers, we just multiply them together. So we've got 8 times 2 times 10, which gives me 160 books. So now we have to try the other rotation. So if we turn the book round, so with the length, for our big box it's still 100, but our smaller one, when we've rotated it here, instead of it being the 12.5 that's the length, we've now got the 19.5. So 19.5 is that way. This one is now my 12.5 and it's still 2 centimeters tall. So length 100 divided by 19.5, which gives me a decimal of 5.12 and some extra. So that is 5 in this case, because like I said, we can't have part of a book. The width, it's 50 centimeters wide, and it's now 12.5 that we've got there. So 50 divided by 12.5, which gives me 4 exactly. And then the height is the same thing because it hasn't changed. So we get 20 divided by 2, which is still 10. So total, which is 5 times 4 times 10, which is 200 books. So therefore, the maximum is 200 books. Where did my marks come here? Let's have a look. With this, your first mark comes from showing that you've got evidence of the fact that you're doing 2 different options. Your second mark is for getting both the 160 and the 200. And then your third mark is for making the conclusion that your maximum is 200 books and communicating it properly at the end of the question. Still going with question 9, it's the 4th book that David has written in a series. The cost of each book is shown in the table. We need to look at our 3 shops, shop A, B and C, and see which one is the cheapest option for buying all 4 books. So if we work out each one individually and then we can compare them at the end. So shop A, tells us that if we buy all 4, we can save 20%. So if we buy all 4, then we have, so our £5.50 plus our £8.50 plus £4 plus £12. So altogether, the books would normally cost £30. So our saving would be 20% on that. So 20% of £30, which is £6. So the cost would be 24. Shop B, straightforward, it just tells us if we buy them all, our cost is going to be £22.99. And finally, so we've got shop C, which is saying if you buy all 4, the 2 most recent ones are published, which you're going to get half price. So that's these 2 at the bottom here are going to be half price. So our total is going to be, so you're still paying £5.50 for the first one, you're still paying £8.50 for the second one, but for the third one, instead of paying £4, you're just going to pay £2, and for the last one, instead of £12, you are going to pay £6. So that gives us the total of £22 exactly. So we can make a comment, so shop C is cheapest for all 4 books as you would pay £22. So marked here for question 9 part D. So the first one is you have to calculate shop A. Second mark is calculating shop C. And then final mark is for communicating and processing your answer and making your conclusion that shop C is the cheapest. Here we have question 10, so that's question 9 over, all the different parts of it. So we have a sports ground which is in the shape of a rectangle and 2 semicircles shown. The running track is shaded in the diagram and we need to calculate the area of the running track. So we have a large shape and the small shape, so we need to find them and take it out. So our area is the area of the large one, take away the area of the small one on the inside. So what I mean by that is our big shape, take away the small one in the inside area here, is going to give us the shaded area. So we need to work out our large area and our small areas. So just the big one, if I'm just going to draw this actually like separate on its own, roughly anyway. So we have a rectangle in the middle and we have 2 semicircles on the end. We know that the whole thing is 90.7 meters. So that's telling us that our diameter for our circle is 90.7 meters. The other thing it is telling us is that for a rectangle, that's 90.7 as well. In here, this 84.4, that is the same here, so this is 84.4 as well, going across to there. So we can work out the area by doing the 2 separate ones. So we've got the area of our rectangle, so I'm just doing A and then a little rectangle. So it's L times B for a rectangle, so this one, 84.4 times by 90.7. So that gives us 7,655.08 meters squared for area. The circle, well here, so we have two semicircles, one on either end. That is just the same as one circle. So we can find the area of the circle, and that is pi r squared. So we need to know what the radius of the circle is. So we've said the diameter is 90.7, so our radius is going to be half of that. So half of 90.7 is 45.35. So pi times 45.35 squared gives us, you should be able to hear me typing on my calculator probably because my headset's quite sensitive. So 0701 and some extra. If we do it to two decimal places, same as the other one, that makes some sense. So we get 07 meters squared. So the large area is those two added together. Which gives us, so 7,655.08 plus our 6,461.07, we get 14,116.15 square meters for the large one. So the small one, again, if I just draw this out so I can visualize and kind of see what's going on. So we know for this one, it's 73.6 meters there. Our rectangle though, still 84.4, that hasn't changed across there. So we know our diameter is 73.6 meters. We can work out the radius by halving it. So 73.6 divided by 2, so we get 36.8 meters. So again, we're finding the area of the rectangle. So this time it is still length times breadth, which is 73.6 times by 84.4. Which is 6,211.84 square meters. For our circle still, it's two semicircles, and two semicircles make a whole circle. So it's pi r squared. So it is pi times 36.8 squared, which gives me 4,254.4704 and some more. So two decimal places again here, 4,254.47 square meters. So the small area, or the one kind of in the middle, is our 6,211.84 plus my 4,254.47, which, oh, I put a subtract into my calculator there by accident, getting ahead of myself. We get 10,466.31 square meters. So our area of the running track, if take those up to here, so it's the large area, so my 14,116.15, take away my 10,466.31, and there I get 3,649.84 square meters for the area of the running track. Marks for this question. So it's out of 5, so there's lots of marks for you to get here. So your first mark was for finding the area of the larger circle here. We get 1 for calculating the area of the smaller circle. In this case, it is doing that the marking scheme says to subtract the areas of the circles. We've kind of done that later on as part of it. We need to calculate the area of both the rectangles. So doing both this rectangle and that one gets us mark 4. Mark 3 is kind of for knowing we need to do a subtraction. And then calculating my overall area by doing that gives me my 5th mark in there. So that is it for that one. So work out both areas, subtract them. The order in which you kind of subtract things doesn't really matter. You would still get the marks whatever way you do it. Right, so question 10, keeping going, part B. So we've got the running track is to be resurfaced. The resurfacing company has 5 workers who can resurface the track of its size in 42 hours. So that's our important kind of information there. So 5 workers, it takes 42 hours. They are now able to provide 2 more workers. There we go. So they all work at the same rate. How long will it take to resurface the track? So this is a question where we have to think about this. So we know 5 workers would take 42 hours. So we're aiming for how long it's going to take 7 workers. This is proportion or ratio, but we need to think, is this direct proportion or indirect proportion? If we think about this, 5 people working on something, all of them working together, it's going to go quicker than if one person did it by themselves. So in this case, because it's going to take less time, it means it is indirect proportion. So that means as I divide this side, I need to times this side. So as one value goes down, the other one goes up. Because one person, it would take you a lot longer to do the task than if you had 5 people. So, to go from 5 to 1, I've divided by 5. So that means the other side I need to times by 5. So 42 times by 5 would be 210 hours. So that'd be an awful long time if you're doing this by yourself. And then here I've times by 7, so the other side I need to do the opposite, because as one goes up, the other one goes down. Which gives me that for 7 workers it would take 30 hours. Marks for this part B. First mark is for realising that it is indirect proportion. So that's kind of recognising that as this side does one thing, the other side does the other. Mark 2 was for getting your 210 hours, and Mark 3 was for dividing to get your 30. So we're keeping with the resurfacing, and we've got 2 parts for part C. So first one, so it says John works for the resurfacing company. His annual salary is £17,108. National insurance is calculated on the person's salary before deductions, such as pension contributions. So we need to calculate John's annual national insurance payment using our national insurance rates in the table. So in here, we need to be careful that up to this amount is taxed at 0. We can see that his salary, if we look up here, is here. So that exists in between this. It is only his money from the £8,424 up to his maximum of £17,108 that is taxed at 12%. The first £8,424 is not taxed at all. So we need to work out how much money is taxed first. So taxable income. And that is going to be his total salary. Take away that £8,424. So when we do that, we get the taxable income he's got is £8,684. So his national insurance is 12% of that. Which is £1,042.08. So part 2 of this question says that he pays 7% of his annual salary into his pension. It tells us his income tax is £1,051.60, and we need to find his annual net pay. So pension money is going to be 7% of his annual income, so that whole lot, so the £17,108. Which is £1,197.56. So net pay is our total annual salary. Take away our 3 deductions that we've got. So we've got £1,197.56 we need to take away. We also need to take away our £1,042.08. And we have to take away our £1,051.60 that we got told in the question for his income tax. So all of those are being subtracted because they're all deductions. And deduction is just another word for take away, or something that is taken away even. So when we do that, we get that his annual net pay is £13,816.76. So for this last question, where do your marks come from? So in part 1 of part C, you get your first mark for realising and knowing you have to deal with the 0% rate. So the fact that there's £8,424 that are not taxed at all. And then second mark is for calculating your 12% correctly. In part 2, we get 1 mark for calculating our pension contribution. And then our second mark is for knowing to subtract and calculating our annual net pay. So that is it for the 2019 paper 2 for applications of maths. As I said at the start, if there's any questions you have about any of the working or anything going on in here, just feel free to leave a comment. And good luck whenever your exam happens to be.